Good morning, good afternoon, good evening, everybody. It is October 4th, back for another Node Operator Roundtable, and today's topic will be Leap 5.0 and what is in and what is out, and any questions anyone's got, and I'll pass it over to Brian to dig more into that.
Excellent. Thanks, Daniel. So some of you might have been on a recent block producer call where it was announced that there were some changes to the plans for Leap 5.0 and Leap 6.0 as well. And if you were not, you might have seen the Leap 5 update blog post that went out, I believe yesterday. I'll share that URL here in chat real quick. So I just wanted to talk about those changes, sort of reiterate what has changed, and then give you a preview of what actually will be in 5.0. I see that Matthew asked for an estimate for an RC1 date. We'll get to that as well. Spoiler alert, it will be this week. That's the plan. So, but I'll come back to that. So yes, I shared a URL to the blog post in case you haven't had a chance to see the update. The high level here is that instant finality, or our implementation of the hot stuff algorithm, which is a consensus change. A change to how consensus works in Antelope, we've decided that it's best to delay that to 6.0, which we're targeting for next year. The blog post goes into detail on the reasons behind that, but ultimately the key message here is that a change to consensus is obviously like fundamental to how any blockchain works, and Antelope and EOS in particular. And so while we're still really, like, we've seen the benefits and that hot stuff can work, right? And that it will achieve the goals that we've set out to achieve. We weren't able to reach a level of confidence in being able to like release it on this time frame without undue risk, which is not something we were, a risk that we thought was prudent to take. So the delay will, buy us time to be really sure that our implementation of hot stuff is, rock solid, and we don't have to worry about any impacts on the network. Having said that, there is still kind of a mind-boggling amount of stuff in Leap 5.0, and a lot of it's really valuable and has some great sort of headlines, so to speak, to share. So what I want to do next is just give you a preview of what's actually going to be in Leap 5. Before I go there, any questions so far? All right. So then in that case, I will, let's see, Daniel, could you give me screen sharing just so that I can have a prop here?
It'll be good now.
Oops. So this is really just a crutch to make it easier for me to talk about this rather than a critical prop. But two things I've got up right now are kind of like our draft release notes. There will be a couple of very small changes to these based on some kind of last minute adjustments, but and an upgrade guide, which will be prettified and clarified more. But I just want to be able to pull to these things to help answer any questions. So yes, 5.0 and all of the notes that I'm showing you here are going to be in the release notes that'll be on the GitHub release. So you'll be able to refer to those once that release goes live. Oh yeah, back to that question. So for 5.0, ideally, we'll be cutting the binary for that this evening, but it should be done this week more definitively. So, and I'll of course be updating on the Antelope Node Operators channel as soon as that is available as well. So folks will, we'll be able to refer to that, and I'll call out anything that's different from what I've talked about here, because there's about 3 things that are right on the edge, but they're, so there's one thing that we might add and 2 things that we might choose to hold. So, based on review. So, okay. So super high level notable changes, sort of flashing here. We are doing a deferred transactions removal via configuration changes. There will also be included a protocol feature to remove deferred transactions, but we're not suggesting to actually go through the protocol upgrade process. It's just there and available primarily for the purposes of being able to do that on test nets if it's deemed prudent to do that by the community. We also, is in a similar vein, we have added a BLS library. So BLS is a crypto primitive that allows for signature aggregation, and it's actually like core to how hot stuff works. But it's also, and you'll see in the notes later, it's also used more widely for other things like implementing zero knowledge proofs and stuff like that. So this is in the Leap code base. There are also host functions as a protocol feature, but again, it falls into this category that we're not suggesting that folks actually activate said protocol feature. So we have some optimizations around memory and CPU, which I'll go into more details on. And we have some peer-to-peer improvements as well, and especially some that are specifically focused around optimizations for sync. And then another support for EOS EVM, which is just the ability to support larger transactions. So going into a bit more detail, whoops, we did talk about the cryptographic primitives. So again, the idea here is that one, having this here helps us from a core development perspective, because we can leverage these libraries. 2, it is possible for developers to leverage this sort of math library, if you will, as a foundation for zero knowledge proof systems. But not a whole lot more to say on that one right now. On the larger EOS EVM transactions, so this is actually a combination of several changes. So for one, we made some changes to the way that certain parameters are applied, the defaults of certain parameters, and also implemented like automatic application of EOS VMOC, which is an optimized sort of version of the virtual machine, where it will apply in certain situations and not others. And all of those things together result in the ability for EOS EVM to support larger transactions, and by larger, we mean more CPU time, right? And so that just unlocks sort of more different kinds of, workloads or use cases for the EOS EVM. It also means that EOS transactions, native EOS transactions can be larger as well. On on the efficiency side, we've got a number of things here. One is that we now have asynchronous block fetching. So this is basically while applying the current sort of batch of blocks, it's Node.EOS will continue to fetch the next batch of blocks, and that's they're independent of each other. So that's just, it makes the process a bit more asynchronous and more seamless, so that syncing can. Oops, I closed the wrong thing there. Syncing can be more efficient. We also have a latency and bandwidth optimizations here. So these are dependent on some options that are now in here, and also have new defaults. So basically, like, one thing that's important that happens here is that latency of peers is tracked and utilized during sync, so that the lowest latency peers are selected for sync. Also, sort of a minor optimization is that I can't remember what notice message, maybe it's literally called notice, there's some added fields so that your peers know what blocks you have, and that way peer selection is done based on who will actually have the blocks you need, to just save some round trips and things like that. There's also the ability to, and this is one of the things that I believe is on the edge, if my memory is serving me right. So this one might fall out, but there's a setting to limit the max bandwidth that is applied to peers for block fetch. So you can take control of make sure that basically, like, syncing nodes don't suck up all your bandwidth, right? On the memory optimization side, this one's pretty exciting from kind of like a headline point of view. I know that, like, the size of state and memory is continues to be a concern. So we had a community contribution during this sort of development cycle, if you will, that then our core team was able to use as the foundation for some further improvements that basically reconstructed the underlying data structures for Chainbase, so that we could have significant savings on the memory footprint of state data. So it's a 20% reduction that we've been able to achieve here on the memory state size in memory. So that's significant. There's actually further optimizations already identified that could achieve another 6% reduction in memory size here. So, beneficial for node operators. On EOS, I imagine this being pretty beneficial for folks on Wax as well, right? So yeah, huge savings there. Let's see, okay, cool. I already talked about that. And then this I already talked about when we were talking about Ethereum, EVM, larger transactions, but this is that auto mode, which is the new default for EOS VMOC enable setting. So it just basically, according to the logic that's in this table that I really probably should have been showing you this view, but nah, whatever, I'm already here. So there's basically some logic where it'll selectively apply that based on whether you're building a block, applying a block, doing speculative execution or computing transactions, read-only transactions, etc. Right? The big boost here comes from the fact that it is applied for system contracts most of the time. I think noticing a little formatting thing that I'm just going to fix while we're at it. Okay. So, and that's actually what enables the larger EOS-EVM transactions, but it also, of course, is beneficial to all EOS system contracts.
There was talk before about allowing this for like non-system contracts in agreement by block producers. Is that still available, or?
It's not something that we've pursued for 5.0. It's still an interesting, sort of topic for further research. There's a lot of thought that for that one that needs to go into, basically just the implications of that. But ultimately, having this globally is desirable, assuming that like we've covered all of the, potential threat vectors of doing so, right?
Yeah, you could effectively do that after this release by creating an EOSIO account and moving the contract there. Now, that might not be appropriate for someone's use case if they don't want to actually move their contract into a different account, but having it in an EOSIO.star account gets you that, which includes, my understanding, Telos' EVM is also in the EOSIO.star account already, and so it would benefit from this as well.
Thanks. On the performance side, we've continued to improve the read performance for read-only transactions. This is something that it's a relatively new feature. We initially introduced read-only transactions in 4.0. We'd love to, see a little bit more experimentation and adoption on the read-only features. Read-only transactions. This in particular will benefit API nodes quite a bit as adoption of read-only transactions picks up. But actually, some of the optimizations that I'm going to talk about here benefit API nodes immediately, right? So if you're an API provider, and you probably want to look closely at 5.0 and consider upgrading. On the read-only transaction side, we had a memory memory cost to multi-threading that really prevented us from having a limit on threading over 8 threads in 4.0. But we were able to make multi-threading for read-only transactions more memory efficient, which allowed us to raise that limit to 128 threads. So you can get significantly higher parallelization of those. We also have some improvements, which I'm going to talk more specifically about in the next piece, but around serialization and deserialization, and some improvements for contract compile time and cache size and things like that all kind of fed into read performance. But yes, the key thing here is that you can set read-only transactions as high as 128 threads. Moving to the serialization improvements, we've got non-blocking serialization, so that has been moved off of the main thread for like ABI intensive requests, resulting in a speed improvement that's like 4 times faster for serialization on those requests. There's also some changes to the time constraints around these sorts of requests, so when they would time out and things like that, and also how the response what's included in the response, right? So certain types of atomic API calls like will always succeed, like even if serialization goes over the limit, because they'll just return with a single object, right? But yeah, the headline here is the four times speed reduction, and this includes some really important calls like get block. Yeah, this is a big boon for API providers, but really for any node, because some of these requests like get block are kind of ubiquitous, right? So, and then we have further refinements to the peer-to-peer network stuff. So we've talked about this one before. Now it's actually going into a release, and that's the sort of customizable endpoints for your API endpoints. So this is basically, we have categories. I won't go over all of them, but chain read only and chain read write and DB size and producer read only and producer read write, those sorts of things, right? And then the endpoints are categorized into those, and you're able to apply server addresses to those categories independently. This is it's implemented in a backward compatible way, because you have to sort of explicitly opt into the feature. But if you're interested in having multiple endpoints, you can now do that. We've also added new fields to the connections API and have the ability to specify listen and server address configurations multiple times. Helping with sort of troubleshooting, we have peer level metrics in Prometheus now. You can kind of see how peers are performing in some of these, specific metrics listed here, which again, you'll be able to reference in the release notes. And IPv6 support for all HTTP endpoints, which, should help with like port remapping and things like that are hassles. There's a few other changes here that are a little less, they're not features per se, like we upgraded to C++ 20, there's the deprecation I mentioned, and then there's, just some other, changes to options, et cetera. I'm not going to go over those today, but they will be in the release notes, along with, of course, the full log of changes. So, and then the other thing we'll be publishing is an upgrade guide that just talks about, sort of anything that's not backwards compatible and any like required steps to upgrade to 5.0. So you'll see that soon. All right, I'm going to stop sharing at least temporarily. I might reshare if it's helpful to answer any questions. But does anybody have any questions or anything they'd like to dig deeper into?
Brian, there's a couple questions in the chat.
Oh, thank you.
I answered one of them, but I think Matthew has another one.
Some of the requested fixes for Prometheus make it in RC1. So we have been working on some of those things. I haven't checked the status yesterday, so I'm not actually sure where that sits, but we have been working on those. Kevin, do you happen to know if those are at a point where they're going to make it in?
Well, yeah, not into RC1. I don't think, if we're going to hold the line on the day.
Oh, that's right. So yeah, so basically the line we're drawing here is for non-critical bugs, we're allowing some of those to slip to happening before the stable. We are avoiding we are avoiding adding things between RC1 and stable that are like, fundamentally make it a different piece of software, like feature or behavioral changes that are significant, right? But yeah, so those are slated to be fixed prior to the 5.0 stable release. You can see, by the way, Matthew, there are milestones applied in GitHub to issues. So if you want to confirm that the 2 milestones that are relevant for this, well, I guess 3, because the absence of, right, to the 3 states are, either there's no milestone or some other milestone, right? Or there's 5.0 RC1 or there's 5.0 stable. And if it's RC1, our intention is to include it in the RC1 release, obviously. And if it's stable, then it'll be in one of the release candidates prior to stable. I think that's it for the questions. And okay. Any other questions?
Was that limitation for the read-only transaction, the one that was like set to max at 8 and now at 128 thread? Did that also apply to HTTP threads or other things? Like for example,
it did, yes. So yeah, and because the it was really only the read-onlys. It was only the execution of the transactions that had the memory constraint. But since it's potentially possible that read-only transactions could have been executed on all threads that you configured, even though there's probably certainly not any out there to use it. But I mean, potentially that's the case, and so it was restricted to 8 because of the memory, the way that the memory was allocated for transaction execution in 4.0, and really before all that. So if you want more detail, I could go into it. It has to do with the fact that before read-only transactions, we only ever executed transactions on a single thread, and so the way we did memory protection on those transactions, right? So those transactions are running in a sandbox, so that if they do something like core dump, or segfault, or do something, in contract that is not proper, you don't want to kill the whole process. Obviously, you want to just kill that transaction, report to the user the transaction failed, and move on, right? So that protection was done in such a way that we gave it a memory region to run in. And since you had, effectively unlimited for a single thread, it didn't worry too much about the way that was implemented. So once we added read-only transactions, that didn't scale the way that was done past what we were comfortable with beyond 8, just in terms of like the virtual memory that's available on a typical, on a 64-bit machine. So that was all reworked, as Brian talked about, in 5.0, so that we did that differently. The way that we do that protection is actually the same, but the way that virtual memory is allocated and associated with those transactions, so that we can then comfortably increase that to 128. But yeah, so that also includes all the things like get info and get block and all those sorts of things that are just read only HTTP.
Yeah, like get table rows and
get table rows. Yeah, exactly. Yeah. Now the other kind of interesting thing, which you probably don't care, but it's interesting to me. The other thing that we did also in 5.0 is that we moved the execution of the read-only transactions off of the main thread, so that they will never run on the main thread. We did that because included in 5.0 is also the fact that we've increased the max transaction execution time, right? So we changed the default of that from 30 to 499, 475. I forget exactly what we changed it to. I did that, but I can't remember. 490. I don't know. Effectively, the block time. And so that what's really constraining transaction execution now is the on-chain consensus parameter. But because of that, that also means that read-only transactions had the ability to run that much longer. So now read-only transactions are only really constrained by the read window configuration that you specified. Well, since we didn't really want to tie up the main thread potentially for that amount of time, 150 milliseconds is what the on-chain consensus parameter is for mainnet, and someone might set their read window actually even larger than that. So we shuffle those off to where they only can execute on read-only threads. In practice, what that means is you have to enable read-only threads to be able to support read-only transactions. If you don't, you'll just get an error back from the API node saying, hey, no read threads are configured, so you can't execute a read-only transaction. But where was I going with that? The HTTP requests like get table rows can still run on the main thread. I don't know that you care, but it's one additional thread that can process those requests while you're in the read window time frame.
Okay, great. Thank you. Yep. We actually do use read-only, and that's very useful.
Oh, cool. Excellent. That's great to hear. Well, I've been doing some tests with in 5.0. It's been really cool. Been running like with 6 threads and bombarding it with our performance harness, our read-only transactions. And I've been able to like watch it running on my local machine. I keep like all 6 read threads completely hot, 100% CPU as we're executing those read-only transactions. And in one run, I noticed I was able to get 6 seconds worth of read-only transactions executed within 1 second amount of time using those 6 threads. So that's pretty cool. So really good parallelization we're seeing on those read-only transactions.
Okay, that's great. Thank you.
Yeah, so thanks for going into those details, Kevin. I wanted to say, 5.0 being a non-consensus release, that is to say a release that we're not sort of advocating any protocol feature activations or anything like that, means that it is ultimately an optional upgrade. So you don't have to upgrade. However, if you are a block producer or an API node, between the CPU improvements and the memory optimizations, I think you'll find it to be significant sort of efficiency and performance gains there. So you might be able to get more out of your node hardware. So yeah. All right. Are there any other questions?
I know. I'm really excited about a lot of the stuff that EOS Release. The enhancements to get block is just really cool. Like how much that it can't fail in the new release 5.0. You'll always get information back, and I think you mentioned it's 4x times faster on the one get block that was problematic that we're testing with, and that not only is it 4 times faster, the time that it's doing that 4x faster is all on a different thread as opposed to it used to be on the main thread. So it's not only is it faster, but it's actually on it's in the HTTP thread pool, which you can configure to do as many of those simultaneously as you like. So it's really cool.
Yep, absolutely. I think it's also some of these optimizations have spawned interesting conversations about next steps. So I'm pretty excited about some of the further improvements that can be made. Which it's not often that you can, for example, shave 20% off of something and still have another thing up your sleeve to make another significant improvement, right? So, well, with that, I guess we can end the 5.0 topic. Are there any other topics that folks wanted to dive into? All right. Yeah, Matthew, very excited, and also, shout out for your early testing on the sort of preview release. That's been helpful to help us get ahead of some bug stuff that we would have been scrambling to fix after the fact. It's really, really helpful. All right. Thanks, everyone. Daniel, back to you.
Well, thank you, Brian. Thank you, everybody, and have a great day. See you in the next one.